Greeting guys, so welcome back. So in this video we'll be seeing GitHubAction for machine learning, and it's a completely beginner tutorial and where we will be learning how to automate machine learning training and evolution using Scikit-learn, GitHub Actions and CML. Let's dive in. Our tutorial series on automating machine learning with GitHub Action and CML. This video continues from the part 1 where we built and trained our machine learning model for predicting customer churn. If you missed part 1, don't worry. I have provided the link in the description below and also in the video above. I recommend checking that out first to get the setup and model building basics. In this part, we are moving on to the exciting stage of setting up CICD, continuous integration and continuous deployment for our machine learning model. We will be using GitHub Action to automate our machine learning pipeline, which will make our workflow more efficient and reliable. So with this CI/CD pipeline, each time we make changes to our model or code, the pipeline will automatically retrain, evaluate and report the results, all through GitHub. To be precise, one of our subscribers requested for this video. Before jumping, if you are passionate about AI and machine learning, I have got something special for you. Simply scan the QR code on the screen to head over to my website where you can subscribe to my free newsletters for AI and ML blogs. Once you are on the site, don't forget to sign up for the newsletters. You will get notified on everything from beginner guide to advanced AI techniques. And if you love in-depth articles, make sure to subscribe to my Substack AI magazine, where I share detailed insights, case studies, and thought pieces in weekly and monthly basis. So why are you waiting? Just scan the code, join the community, let's learn and do together. Execution matrix here, 223 which is true negative. The model correctly predicted that 223 customers would stay, the label 0, and indeed they stayed. So this is successful predictions for customers who are not churning. And then here we have 51 which is 18 which is true positive. The model correctly predicted that customers would leave, label 1, and indeed they left. So this is a successful prediction for customers who are churning. And we will be having our false negative which is 8. So the model predicts that 8 customers would stay, label 0, but these customers actually left or churned. So these false negative indicates missing churns where the model underestimate the risk of customer leaving. And then we'll be having the false positive. Here it's 51. So the model predicted that 51 customers would leave level 1, but they actually stayed. So these false positives represent cases where the model incorrectly flagged loyal customers as at risk of churning. Okay, so let's see the matrices.txt. So it just printed only the accuracy and then f_, and the pipeline is saved here in this file. Okay, so now what we will be doing is we will be pushing all these files to our GitHub repository. Not all the files. We don't need, like, for example, model result, matrices, churn pipeline, as it can be generated during the CICD like pipeline. Once we push our model, the build will be happen where we will be writing the GitHub action workflow file. So this will try to run this train script and then just take the generated result as a report. So we'll be seeing this in detail. Okay, for this, so we need a Git large file storage. So, and to track these files with churn modeling CSV, and Git LFS allows you to store large files, so like datasets, images, or like model weights separately from the main Git repository. This avoids bloating the repository size, which keeps it faster and more manageable. And also it helps in avoid Git repository size limits. Regular GitHub repositories aren't optimized for large binary files. On GitHub there is 100 MB file size limit and a recommended maximum repository size of around 1 GB. So by using Git LFS, you can avoid hitting these limits. So for that we have to install Git LFS. For that I will be doing conda install conda forge Git LFS. So you just try to install the Git LFS in our current environment. Basically, this is often a simpler installation method for users working in Conda's environment. So now, okay, there is some issue with my command. Let me, yes, it is Conda Forge. Okay, so it just says all the required packages already installed. Okay, as I have already installed Git LFS in my environment. Okay, now we have to initialize the Git LFS for our repository, and this command which will enable the repository to track the large files using Git LFS. That Git LFS install. Okay, so Git LFS initialized. So once it's done, we have to tell the Git to track the churn model, which is churn modeling CSV, as a large file. So this command will create a Git attributes file, which will instruct the Git to store the churn modeling CSV in LFS storage instead of the main repository. So for that, let me do Git LFS track churn modeling.csv. So this is something an additional tips in this tutorial. If you are dealing with like large file system as your data set, then you can make use of this step. Okay, otherwise simply you can just push the CSV file in the Git and you can just try to build your CICD pipeline using GitHub actions. Okay, now we are done with LFS. So let's see git status to see what are the files which are available. So basically from here, let me go to GitHub plugin. You can install this plugin from, by default it's installed while you are installing VSCode. If it's not, you can install it from the extension. Let me add all the files that I need in my repository. So we need our requirement.txt and then train file. Let me add all these generated file from our churn pipeline in the Git ignore. Okay, for example, let me add the churn pipeline file, metrics file, and even the model result file. Okay, let's add the Git ignore file as well in staging, and let's try to write the comment. Okay, so this is churn model pipeline. Now let's commit, and we can do the push from here as well. Otherwise I will push it from here as well. Git push. So it will just gives us like message LFS object is uploading. Now we're done with our git push. Let's see the repository from here. So this is a repository that we have created, and we have just pushed the code. Let me refresh it. So if you see, we have all our file which is included here. So this is a basic like your model training pipeline. You build your model pipeline and then you push it to GitHub. So now we are in the main stage, which is we have to create the GitHub action. For that, we have to go here to action tab. Once you are here, you have set off other plugins which comes with actions, but we will be just setting up our actions using our manual workflow. Okay, so set up a workflow yourself. So by default it will create a main.yml file for this. So now we have to write our YAML file. So as I said, like GitHub actions which provide the automation with GitHub projects. So for machine learning, automating the model training, evolution, and code formatting ensures that consistent quality, faster experimentation, and also easy sharing of results, all in an accessible version controlled environment. So YAML file which helps in configuring the workflow in GitHub actions due to their simplicity, readability, and hierarchical structure. So which suits as a step-by-step configuration like that we will be seeing later. So in this YAML file, we will have each action, conditions, and steps in machine learning workflow which is clearly defined and making it easily to update and share. So for to start with it, we have to name the ML workflow, which is for identifying easily using within GitHub. Okay, let me name it as ML workflow, for example, in our case, and will be on, which specifies the events that triggers this workflow. So these actions are push. This will execute when the code is pushed to the main branch. For example, branches is just main. Sorry, let me give the tab like this, and then pull request, which runs when the pull request targets the main branch. So we will be running the pipeline even during the merge. So here branches are again made. And then workflow dispatch, okay, which allows the manual triggering of the workflow. So to define this, we will be using workflow key, workflow dispatch. And again, we will be having permission, which is write all currently, which will grant write access to the repository needed to like store and comment on reports in pull request or commits. Let me write permission, which is write all. And now we have to define a job, okay, which is build that contains our machine learning task. We'll be having a run on which specifies the OS. Here we will be using Ubuntu to execute this workflow, okay. And now we have to define the steps in the job. So each step which performs a task sequentially. So let me just initiate steps first. There's an error here in the permission, which is permissions. Sorry. So once after build, there is a tab issue. So we have to correct all this, otherwise we will be end up with errors. Okay, so in steps we will be having users. So what it will do is it's a checkout code block which uses the action checkout to clone the code base into the runner environment. To do that, we will be using users actions checkout. So it's basically at version 3. So this helps to like access all the repository files including the dataset. Again, we have to define the users as iterative dot setup CML. So using this action to install the CML packages. So now we will be doing name install packages, where we will be running pip install upgrade the pip package pip install requirement.txt. Let me write it in online. So this will create the run for installing all the Python packages that we need. And also we have to create the run for formatting the Python file. For that, we'll be using black library. Write the name of this run. Run will be for all the Python files in the repository. So we'll be using wildcard here. And then we have to create the run for training and evaluating the model. To do that, let me name the run as train. Where it will be calling the python train.py file. And then we will do the evaluation, where name of the run will be evaluation, and then here the environment. So we have to create the run with GitHub tokens for moving the model matrices and confusion matrix plots to report.md. So then this use the CML command to like create the report under the commit command. Okay, for to do that we need GitHub tokens. Okay, so there is no need to like explicitly just write your GitHub token. You can just do in the following way that I will be showcased now. So this will automatically grab the GitHub token for this action. So if you want to learn more on this thing, I would suggest going through this documentation. That could help. I will provide the link to this documentation in the description below to know how we can make use of a GitHub token secrets in our GitHub action workflow. So now we have to run. So now we have to run the evaluation job. So uses the GitHub token to authenticate and create the commands on GitHub. So once it's done, we have to do the reporting. So for to do that, we have to run the job evaluation. So now we have to like do the reporting. So basically it will opens the report.md to store the model matrices links to the generated plots, and this will append the contents from metrics.txt here using cat, and then like model matrices like accuracy and fn score to the report.md, and then adds the link to the confusion matrix and then model result.png as markdown image tags so that they will display in line. And then the last thing that we will be doing is CML command create a report.md. This command will post the report.md as a command in the pull request or commit, making the result easily viewable in GitHub. So let's do that. So that's it. Now we're done with our build function. I don't know, maybe I have some issues with you see there are some indentation issue that we have like fixed. Okay, so this is the basic workflow that we built. Let's commit this. So it will create the main YML. So once we commit our main YML, it will start the build process for the repository. Let's do it. For to see the build actions, we can go here to actions, and in the create main YML, you can click here. So the build process in progress. Let me click the build. You see it's in the installing package process. It just have completed the setting up the jobs and check out the branch in the. It will set up the CML and then install the packages and just formatted the Python files, and it just started the training file. And if you see, it just have logged the messages here. So these are the things that we saw earlier in the run in our local machine. So it just did it in an automated way. Whenever you're do the push in GitHub, it will just try to run all these jobs which are like written in our workflow file. So like it just generated the report.md and it just did the final action to put it, and then finally it just cleans up the offline process. Okay, so let's see the commit that it have written with the message. So you can click this commit ID, it will go here. Oh, wonderful. So now we can see this commit. We have our accuracy and FN score, and then we have our confusion matrix as well. So that's it. This is how like you can make use of GitHub Actions for machine learning operations. Let's do some other changes in the training file, and let's push it into main and to see whether how this GitHub action is invoking the build pipeline. Let's do it. So for that we have to add like a ROC curve as well. I will be adding the ROC curve in our training and .py file. So let's test with. I'll be adding the ROC curve, which will allows us to like visualize the model performance across different threshold values, giving the insights into like how sensitive the model is to like identifying churners while minimizing the false positive. So by analyzing the ROC curve, you can like choose an optimal threshold based on your business objectives. You might like prefer like higher sensitivity if the retaining customer is a priority. So let's do it. For to do that, I have added like a ROC curve in our workflow file as well, but currently it won't return anything. Okay, if we saw like our actions in the build. So in our workflow, we have added a ROC curve PNG, but we haven't added this in our training file yet. So it just gives an empty image here. So let's add this ROC curve method in our training.py file, and then test it with the workflow. Okay. So for to do that, let me go back here to the train. So this time we will be creating a new branch in GitHub, and then try to like do the pull request, and then to see whether the GitHub action is like running the build job via the pull request to the main. Okay, for that let me go to here to the terminal. So you have only main branch. So now we have to create a new branch, and we'll be trying to add this ROC curve in the new branch, and we'll be creating the pull request. And while this pull request is merged to main, the GitHub action pipeline will start the building process, and yeah, it will build, and it will provide a report of our model in real time using the CML. Okay, let's test this part. For that, we will be doing git checkout. The branch name will be feature adding ROC Curve, for example. So we have a new branch which is created. So in this new branch, I will be trying to add the plot ROC Curve function here. So let me do it here. I will be defined plot ROC Curve. Print the log message as plotting ROC Curve. The purpose of this method is to plot and save the receiver operating characteristic curve, which is useful for like assessing the performance of a binary classifier. So basically it will compute the predicted probabilities for the positive class using predict proba. Let's do that. Calling the model pipeline and then predict proba. And then we'll be calculating the false positive rate and the true positive rate, which is TPR and FPR, using the ROC curve function. So FPR, TPR, we have the ROC curve function. We'll be giving our Y test and Y props. So now we will be plotting the ROC curve and highlights the area under the curve, which is AUC score, indicating the model performance. And then we'll be saving the ROC curve as an image file in the rockcurve.png for reporting. Okay, for to plot and save this image, we can plot and save the image in rockcurve.png finally. Okay, we add the like doc string as well. Yeah, now it's done. So once we have added the ROC curve, we have to call it here. So that's it. Let me run this quickly. So now this time it just output the ROC curve as well. So as I said, like we have the true positive rate, which are also known as like recall. It represents the proportion of the actual positives that were currently identified as such. And then we have false positive rate, which is FPR, which represents the proportion of like actual negatives that were incorrectly identified as positive. So basically, what are the importance of ROC curve is like it helps in threshold variations. The ROC curve shows the how the true positive rates and the false positive rates change with a different threshold for like predicting churn. And then by adjusting the threshold, you can like control the trade-off between the sensitivity and specificity. And area under curve like AUC as well, like we can add AUC as well, which will provide the single measures of model ability to discriminate between the classes. If we have 1.0, which indicates the perfect classification, 0.5, which indicates no discriminative ability, which is like random guessing, and then if it's lesser than 0.5, indicates like worse than random guessing. So basically, this allows to visualize the model performance across different threshold values, giving like insights into how sensitive the model is to like identifying churners while minimizing the false positive. So by analyzing the ROC curve, we can like choose an optimal threshold based on our business objective. So now the objective is to like push this ROC curve implementation in the feature branch, and then we will be creating the pull request from GitHub to merge it with the main. So let me just add this to git ignore as it will be created when the GithubAction will build the pipeline during the merge. So add it to git ignore. So if you see, we have added only the ROC Curve implementation. Let's stage these changes and write the commit message. So let's publish the branch and push the commits to the feature branch here. You can do it by git push feature adding ROC Curve as well. Otherwise, we can from VSCode we can just simply publish it with a simple click. So let me see. Let me go back here to the GitHub. So now we are in our repository. So now if you see, we haven't have any actions which is invoked, as we haven't designed our workflow for any other branch other than main. So let me go here to the new branch where we have added our recent commit for ROC Curve. Let me compare and pull. Let's create a pull request. So this pull request will be for like merging the feature branch to main. For example, right now ROC Curve integration and create pull request. Great. So once we have a full request is started to the main, it just started the GitHub action build. Okay, so where you can see the status of the build here. As usual, it just try to check out the branch and then install the necessary packages, and then it will format the file, and then it will run the training script and then evaluation, and then it will write this in the report.md. Great, quite amazing. Let me go back to the pull request window here. Let me refresh the window. That's it. In our pull request, if you see, it just generated the graph, and it just says there is no conflict with the main branch, and then all the checks have been passed, and then yeah. So here is the result of our current branch. So this helps in to decide whether we can just merge this branch to the main or not, because in machine learning, which is really important, if we change some of the pipeline or transformations in our machine learning pipeline, we should be more guaranteed that okay, it works. We have to be assured that it works as we need. So now we can able to merge this pull request. Okay, so for example, we have only one pull request, which we go here. Now I can merge the pull request. So we can add the description here, commit message, ROC Curve added. So this will merge the feature branch to the main, like confirm the merge. So pull request successfully merged. You can delete the branch if you want. But let me go here to the main branch. So it's just have got like merge pull request. If you see here, so the job is running, like workflow job is running right now. As whenever we do the pull request to the main, we just configured our workflow as like it should execute all the jobs, and as well whenever we do the commit in main, the workflow file which will do the build process. Let's wait for the build to complete. Okay, now it's done. So that's it, guys. So this is how GitHub Actions works with CML for the machine learning operations. As well, sometimes you can receive the mail as well for recording the pull request if you have set up your GitHub in such a way. So I have provided the code resources that we have used in this tutorial in the description below. Do not hesitate to try it by your own. So if you see, we have our GitHub Action plugin that I have installed from here. So if you type GitHub Action, so you can install this plugin to visualize the list of the jobs which are currently running in your current branch or in your current repository. For example, in our main branch we have 3 workflow which have already ran successfully. So this is the workflow detail. So I have 4 workflows so that we have including our request. So let me also show you the branch directly. If you see, these are the actions that have been already done with our branch and with our pull request. If you want to learn more detail about the actions or the jobs, you can go into it and you can click build. You can see how it just ran. So if it was failed, then it will give a red mark, cross mark, saying that the job was failed. So that's it, guys. We are at the end of the tutorial. So machine learning operation MLOps is a vast field that requires knowledge of various tools and